Hello and welcome you all. This is Professor Rajesh Barapate, a book author of 25 plus engineering books. Dear students, today's topic is electromagnetic induction. I shall teach you how to solve numericals on electromagnetic induction. Dear students, I am advising you to please watch earlier two videos which are related to prerequisite of this chapter and the concept of magnetism. So I will provide the link of those videos in the description box. Please watch those videos. Presently, we are talking about electromagnetic induction. First, we will discuss one definition. A property of a coil to oppose the change in current flowing through it is self-inductance. Self-inductance is denoted by small e. I have made a list of formulae. Do remember, there are plenty formulae in this subject, but I have made the list of only those formulas which are required for solving the numerical. So first is E, that is self-inductance, is minus L di by dt. I is the current. L is called as coefficient of self-inductance, which is given by N square. This big N, capital N, is representing number of turns. Mu 0 is permeability of free space. Mu r is relative permeability. A is cross-sectional area. L is the length of wire. All these terms will be more clear to you while solving the numericals. Next is reluctance. What is a reluctance? Reluctance is basically opposition created by the medium to flow of the magnetic lines. So S is reluctance, L again length or circumference of ring upon mu 0 mu r into A. Next is MMF, that is a magnetomotive force. Certain force is required so that magnetic lines can pass through the medium. It is MMF, which is given by phi into S. Phi is magnetic flux, S is again reluctance. One more equation we have, N into I. I is current, N number of turns. From this equation I can well write, from these two equations I can well write I is equals to MMF upon N. And the last formula which is required is MMF is B is magnetic flux density into S is reluctance into A is cross-sectional area. Let us solve few numericals so that you will come to know how to make use of this formula. First numerical, the question is find induced EMF in a coil having inductance 0.15 H. H is Henry's unit of inductance. When, first part, current of 10 amperes is switched off in 0.01 seconds. That means initially current of 10 ampere was flowing, it is switched off in 0.01 second, and second part, same current is reversed in 0.01 second. Now we have the list of formulae. So first equation is the equation for self-inductance, which is given by E is equals to minus L di by dt. Why I selected this formula? It is clearly mentioned, find induced EMF. This is the equation of induced EMF. L is the given value of inductance, which is 0.15 Henrys. I need to think about di by dt. Now, let us write the terms separately. Di is change in current. Look at the question carefully. Current of 10 amperes is switched off in 0.01 seconds. So, current is switched off, means initially current was 10 amperes, it becomes 0. Di represents change in current. So, if I want to write it in simple language, I can write it like this: final current minus initial current or starting current. Very simple. Di is change in current, which is final current minus initial current. What is mentioned in the question? Current of 10 ampere is switched off in 0.01 second. That means initially there was a current of 10 ampere which was switched off. So current becomes 0. Switch off means 0. So final current is 0 minus initial current is 10 ampere. So that is minus 10. This is the value of Di. Di is change in current. Then what about dt? Dt is change in time, which is directly given in the question in time period 0.01 seconds. So what we need to do, we have to make use of this formula. So just I need to put the values in this formula. So E is equals to minus L, that is minus 0.15 into value of di. di is final current minus initial current, which is minus 10 into minus 10 upon 0.01. You just have to perform this calculation. Do remember minus minus become plus. So after completion of this calculation, this answer is 150. What about the unit? This is value of induced EMF. Do remember one word. EMF is electromotive force, which is same as the voltage. So its unit is volt. This is about the first part. Look at the second part. In the second part it is mentioned same current is reversed in 0.01 seconds, and of course you need to calculate induced EMF. So I will be making use of same formula. Value of di will be changed. Now listen carefully. What is mentioned? Same current is reversed. Reverse means initially current was 10 amperes. After reversing it becomes minus 10. So I will write this as minus 10. After reversing means changing the polarity, it becomes minus 10 minus initial current. Initial current is given in the question minus 10. So it becomes minus 20. dt is again given in the question like the previous case. It is 0.01 second. So simply put the values in this formula. So you will get E is equals to minus sign as it is 0.15. This is value of L. Then di by dt, value of di is minus 20 upon value of dt, that is 0.01. If you solve this on the calci, you will come to know this answer is 300, unit is volt. Now let us solve one more numerical. Next numerical is an iron ring of mean diameter 20 centimeter. Keep in mind this is diameter, not the radius. Has square cross section 2 centimeter into 2 centimeter. That means it becomes 4 centimeter square. This is cross sectional area. As I mentioned in the earlier videos, while writing the numerical itself, be habited of writing in terms of notation. So this is the diameter. I need length. Length is the circumference, which is given as 2 pi r. It can be well written as pi into d, because 2 into r is diameter, so it is pi into d. D is the diameter, so I can well write this as pi into 20, that is 20 pi, but this is in centimeters, so I need to write 10 raised to minus 2, because we know the well-known relation, 1 centimeter is 10 raised to minus 2 meters. So this is 20 pi into 10 raised to minus 2. This is the value of L. Has square cross section. This is the area. Area is denoted by small a, which is 2 centimeter into 2 centimeter, that is 4 centimeter square. If you want to convert it into meters, don't make common mistake. We know that 1 centimeter is 10 raised to minus 2 meters, but it is centimeter square. So this 4 must be multiplied by 10 raised to minus 4. Then it becomes meter square. This is the area. Uniformly wound with 600 turns. Number of turns is denoted by N, big N. So it is 600 turns. N is 600. Mu r, that is relative permeability, is given in the question, that is 1000. Now, first part, calculate self-inductance. Question arises, which formula is applicable? Very simple. Do remember the basic words. Self-inductance is same as coefficient of self-inductance, no other meaning. So directly we have the ready-made formula. I can't use this formula because this is for the EMF. So I have to make use of this formula, that is L is equals to N square mu 0 mu r A upon small l. Simply I need to put the values in this formula. This is very much straightforward. So N square, value of N is, we have written 600, it becomes 600 square into mu 0. Mu 0 is permeability of free space. Do remember this value, it is 4 pi into 10 raised to minus 7. This is fixed value, which is permeability of free space. So put the value 4 pi into 10 raised to minus 7 into mu r is 1000. It is given in the question, into A, value of A we have written 4 into 10 raised to minus 4 divided by value of L. L we have just calculated, L is the length, or it is, in case of a ring, it is called as circumference. So it is 20 pi into 10 raised to minus 2. You just have to perform this calculation on the calculator and you will get the answer of L as 0.2872. This is the value of inductance, rather self-inductance. Since it is inductance, do remember unit of inductance is Henry's, written as capital H. This is the first part. What we did, we calculated self-inductance of a coil. Now second part, new value of inductance if mu r is doubled. Very simple. Same equation I will be using. What will be the change? Change will be, this is the value of mu r, which is given as 1000. If it is doubled, I will have to make it 2000. That's it. If you don't want to repeat the calculation again and again, very simple trick. What will be the change? This value will be doubled. Even if you cross check it on the calculator, you will get the same thing. So this is the answer of first part. For the second part, simply this value will be doubled and you will get direct answer as 0.574 unit is Henry. Let us solve one more numerical related to this. Next problem is an iron ring of mean diameter 25 centimeter. Like the previous sum, diameter D is given, which is 25 centimeter. For calculation, we need a length or circumference. So L is equals to 2 pi r, that is pi d, which is 25 pi. But like the previous sum, this is given in centimeter. So multiply it with 10 raised to minus 2 to convert it in terms of meters. Of 25 centimeter, mu r is 1000. Mu r is relative permeability, which is 1000. Is uniformly wound with 500 turns. So number of turns is 500. As I mentioned in earlier numerical, be habitual of writing the values in terms of notation while reading the question itself. Find current required to produce a flux density of 1 Tesla. It is the unit of flux density. Flux density is denoted by B and it is 1 Tesla in the ring. These are the given values. It is asked to calculate the value of current. Now the question arises, how to start the numerical? Is there any formula in our list which is related to current? Yes, we have one formula. So first, from the exam point of view, I'm telling like this. First, go on writing the formula which is applicable. So I will write it like this: I is equals to mmf upon n, which is the available formula. But for this, I need the value of mmf. Mmf is magnetomotive force. Check the formula available for mmf. One formula is this: phi into s. Phi is not given in the question. Then ni. From this itself, I have written this formula. One more formula we have. So I will make a list like this: mmf is equals to bsa. Why I choose this formula? Because this we already used. Phi is not given, so it's of no use. And another formula is in terms of b. Value of b is given in the question, so bsa. I have written it. But again the question arises, I don't know the value of s. S is called as a reluctance. Then how to do the calculation of reluctance? We have a ready-made formula of reluctance. S is equals to L upon mu 0 mu r into A. A big question. Here also I have written A. In equation of reluctance also I have value of A. A is cross-sectional area, which is not at all given in the question. Keep in mind, whenever any such values are not given, go on calculating it by keeping A as it is. Automatically it will get cancelled. I will show you how it happens. So how I started? First I wrote the formula of I, then in that I need mmf. I wrote the equation of formula of mmf. Then in this formula I need S. S is reluctance, so I wrote the formula of reluctance. Now do the calculation, start doing the calculation in reverse way. That means first I need to calculate S. So go on putting the values. S is L upon mu 0 mu r A. So as I said, A is cross-sectional area, which is not given. I will keep it as it is. So L is, we just now wrote this value 25 pi into 10 raised to minus 2 upon value of mu 0 is 4 pi into 10 raised to minus 7, which I have explained earlier, into mu r. Mu r is given as 1000. Here also we have written it is 1000 into A, because value of cross sectional area is not known. So keeping A as it is, I have to calculate value of S. So this becomes 625 upon A. What I did, I simply calculated the value of S, which is 625 upon A. Next part is, I have to calculate the value of MMF. MMF is magnetomotive force, which is BS into A. So I will write it like this: MMF is equals to BSA. Simply I have written the formula. I will be putting the values. So value of B is 1. S just now we calculated, it is 625 upon A into, this is the value of S, into A as it is. So as I mentioned earlier, area of cross section is not given, it gets cancelled automatically. So this value of MMF becomes 625. Now refer the very first formula which we have written. It is MMF upon N. So the current flowing is MMF, I am making use of this formula, MMF upon N. Value of magnetomotive force is 625 upon N is number of turns upon 500. So answer of the current flowing through this is 1.25 amperes. This is the way how you can solve the numericals if you have the list of formula. Now listen carefully. Another variation could be like this. If suppose as an extension of this numerical, if it is mentioned there is some air gap of say 1 mm, then do the calculation of current. Very simple. We did the calculation for normal ring. If suppose there is an air gap, what will change? Only value of L will be changed. Remaining formulae calculations will be as it is. I mean only values will be changed. Final answer will be the value of second current I2 due to air ring. But I think this numerical is sufficient to get the concept clear as far as magnetic induction is concerned. Dear students, I have provided you the list of formulae which are required to solve the numericals on magnetic induction. If you want more solved numericals, then let me know in the comment section. And if you like this video, don't forget to smash the like button. And if you haven't subscribed the channel, do subscribe the channel. Thanks for watching this video. Thank you very much.